Right, so let's check your analysis and see how you did on these limits. For number 1, the first 5 terms are given by 0.75, 0.5625, 0.5278, 0.516, 0.51, 0.507. So remember, this is where n equals 1, 2, 3, n equals 4, 5, 6. And I can see, since I plugged in 2, all the following integers, it looks like that my limit or the sequence is converging to 0.5. So we would say that the limit is equal to 0.5. Now I know there's no limit notation over here, but remember we discussed earlier in the previous bullet points that when we're finding the limits of a sequence, we are looking for the limit as n approaches positive infinity. Recall that the values we plug into n begin with 1 and just increase from there. Number 2, if we find the first 5 terms, we have 2.5, 4.25, 6.67, doesn't look like it's converging yet, 8.25, 10.1. So far, I don't really sense a pattern that this is converging. So I personally decided to go ahead and jump way out to, so I've got the first 1, 2, 3, 4, 5 terms. I decided to jump out to the 100th term, and I found that when n equals 100, that the 100th term, I found that the 100th term was equivalent to 200.05. Now, there's nothing magical about the 100th term. I could have chosen the 9th term. I could have chosen to find the 10th through the 20th term. I could have chosen to find the 1000th. But remember, my thought is as n gets bigger and bigger, this value is not converging on any number. So I can say that this sequence does not converge to a unique number, so the limit does not exist. On example 3, my first term is 0.6, the second term is 0.625, the third term is 0.538, 0.45, 0.379, 0.325. So far, when I look at the first 3 terms, when n equals 1, 2, 3, 4, 5, and even the 6th term, so far, I might be tempted to stop right here and say, okay, well, it's converging on 3. But I don't see a clear change, a clear minute change like I did in number 1. I don't see an overt divergence like I did in number 2, so I'm going to keep going. So I decided to go ahead and plug in 100, and when I found a sub 100, I had gone from 0.32 to 0.02. I decided that, then I started to think, okay, I think I know what I'm converging on, but I decided to go ahead and try 1000. So I tried a sub 1000, and that gave me this value of 0.002. So what I'm noticing is as n gets bigger and bigger and bigger, my y value is changing very slightly, but I think it's converging to 0. And so I would say here that my limit is 0. So notice what I did. On number 1, it was very clear to me that I was converging on 0.5. But 2 and 3, it was not quite so clear. So I jumped way out in the sequence closer to positive infinity. And of course, we know that 100, even 1000, is nowhere near positive infinity. But I was moving closer to it to check my convergence. So now you'll see that we have a limit of 1/2 does not exist in 0. And then if you go back and look at these 3 sequences, you'll notice that the first sequence is a rational function. It has equal degrees, and the ratio of 2/4 is 0.5. In number 2, you'll see that the degree in the numerator is 2 and the denominator is 1, and it's top heavy. top-heavy rational functions have no horizontal asymptote, our limit does not exist. In number 3, you'll see our degree is bottom-heavy, and therefore our limit is 0. So, with sequences, if we have a sequence of a rational function, we can compare the degrees of the function, and still we're seeing that we're still looking at top-heavy, bottom-heavy, or equal. Now, if you have to find the limit of a sequence that's not set up as a rational function, then you now know how to evaluate that sequence. Find the first 5 or 6 terms, and if you're not sure about the value that you are converging on, then jump out to 100, 1,000, maybe even 10,000.